Here is a question on the screen that in triangle ABC, AD is perpendicular to BC. Prove that AC square is equal to AB square plus BC square minus 2BC into BD. Friends, here it is given that ABC is a triangle and AD is perpendicular to side BC. AD is perpendicular to side BC. And we have to prove that AC square, thus AC square, that is equal to AB square plus BC square minus twice of BC into BD. So first what we will do, we will take triangle ABD. So in triangle ABD, since AD is perpendicular to BC, this angle is 90 degree and triangle ABD is a right angle triangle, and so we can apply Pythagoras theorem here. In triangle ABD, AD is perpendicular to BC, and therefore AB square, square of the hypotenuse, that is equal to AD square plus BD square. This is by Pythagoras theorem. This is by Pythagoras theorem. And now I take BD square to other side, and you will get AD square, that is equal to AB square minus BD square, AB square minus BD square. Let this be equation number 1. And now similarly we will take triangle ADC. In triangle ADC, in this triangle AC square, AC is the hypotenuse, so square of the hypotenuse, that is equal to sum of the squares of the other two sides, and so it will be AD square plus DC square. So AD square plus DC square. But from 1 we know that AD square is equal to AB square minus BD square, and so this we can write as AC square, which is equal to AD square, that is equal to what? AB square minus BD square. So it is AB square minus BD square. But here this DC, this is DC, this DC can be written as BC minus BD. This total length BC minus BD, that will be equal to DC. So in place of DC I write here as BC minus BD bracket square. Now opening this bracket, so it will be AB square minus BD square, AB square minus BD square plus this is A minus B bracket square, that is A square minus B plus B square minus 2AB. So it will be BC square, A square plus B square, that is BD square minus 2AB. So minus 2 into BC into BD, BC into BD. And now here friends, this BD square and BD square will get cancelled, and you will get AC square, that is equal to AB square plus BC square minus twice of BC into BD. And that only we have to prove, and hence it is proved. Now here is a question that prove that sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Friends, here we have to prove that the sum of the squares of the four sides of a rhombus is equal to sum of the squares of the hypotenuse. It means what we have to prove? We have to prove that AB square plus BC square plus CD square plus AD square. This is what? It is a sum of the squares of the four sides of a rhombus, that is equal to sum of the squares of the hypotenuse, that is AC square plus BD square. AC is a AC is a diagonal and BD is a diagonal, and this is the sum of the squares of the diagonals of the rhombus. Now here we know that the diagonals of the rhombus bisect each other, and therefore AO will be equal to OC, AO will be equal to OC, and DO that will be equal to OB, because the diagonals of the rhombus bisect each other and all the four sides of the diagonals are equal. So four sides of these diagonals, all four sides are equal, of the rhombus are equal. So here we know that AC is perpendicular to BD. AC is perpendicular to BD. This AC is perpendicular to BD because the diagonals of the rhombus bisect each other perpendicularly, so this angle will be of 90 degree, and so these two are perpendicular to each other. So AC is perpendicular to BD, and also OA is equal to OC. This OA that is equal to OC, and OD is equal to OB. The reason to these two statements will be what? The diagonals of a rhombus bisect each other perpendicularly, and therefore here we can take this triangle AOB in triangle AOB. In this triangle, this angle is 90 degrees, so this is a right angle triangle, and therefore we can say that AB square that is equal to AO square plus OB square. This is AB square. We are applying the Pythagoras theorem. Square of the hypotenuse is equal to sum of the squares of the other two sides. So this is by Pythagoras theorem. But here AO can be written as half of AC, correct? Because this AO and OC are equal, and therefore AO can be written as half of AC. So this AB square that is equal to half of AC, that is AC upon 2 bracket square, plus this OB2 can be written as half of BD, so it is BD upon 2 bracket square. Now we will solve this further. So here we will take the square of these brackets, so it will be AB square that is equal to AC square upon 4 plus BD square upon 4. So 4 will be the common denominator, so take 4 to this side, so it will be 4 AB square which is equal to AC square plus BD square. But here 4AB square, that means what? AB square plus AB square plus AB square plus AB square, but all the four sides are equal, so this 4AB square we can write as AB square plus BC square plus CD square plus AD square, because all four sides of the rhombus are equal, which is equal to AC square plus BD square. Sides of a rhombus are equal, and therefore here we have proved that sum of the squares of the four sides of a rhombus is equal to sum of the squares of its diagonals, and it is hence proved. Now here is a question on the screen. In triangle ABC, AD is perpendicular to BC such that AD square is equal to BD into CD, prove that ABC is a right angled triangle. Here it is given that ABC is a triangle in which AD is perpendicular to BC. It means this is 90 degree and this will be also 90 degree. So here AD is perpendicular to BC, that is given, and it is also given that AD square that is equal to BD into CD. This is given. So AD square that is equal to BD into DC, this is given, and we have to show that triangle ABC is a right angled triangle. So let this angle be number 3. This angle is 1, this angle is 2, and this angle is 4. Now here it is given that in triangle BDA, and triangle ADC, in this triangle and this triangle ADC, triangle ADC, it is given that AD square is equal to BD into CD. And since this we can write as AD into AD, then it means what? AD into AD, which is equal to BD into CD. So if you take AD to this side, it will be BD upon AD, that is equal to, if you take CD to other side, it will be AD upon CD. It means it is given that these ratios are equal. So in these two triangles, BD upon AD, that is equal to AD upon BC, and also these two angles are each 90 degrees, so these two angles are also equal. So angle BDA is equal to angle ADC, each is equal to 90 degree, because AD is perpendicular to BC, and therefore these two triangles will be similar triangle by SAS similarity rule, because these two ratios are equal and these two angles are also equal. BD upon AD is equal to AD upon DC, and the angles included by these two are also equal, and therefore triangle BDA is similar to triangle ADC. Reason will be what? SAS similarity rule. And since these two triangles are similar, their corresponding angles will also be equal. So angle 3 is equal to angle 2, angle 3, therefore angle 3 is equal to angle 2, and angle 4 is equal to angle 1, because the corresponding angles of the similar triangle are equal. Now in triangle ABC, sum of the three angles of a triangle is 180 degree. So angle 3 plus angle this, it means angle 1 plus angle 2 plus angle 4, that will be equal to 180 degrees. So angle 3 plus angle 1 plus angle 2 plus angle 4, that is equal to 180 degree. But angle 3 is equal to what? It is angle 2. So this is angle 2 plus angle 1 plus angle 2, and angle 4, here angle 4 is equal to angle 1, and so it will be plus angle 1, which is equal to 180 degree. Now angle 1 plus angle 1, that is twice of angle 1. Angle 2 plus angle 2, that will be twice of angle 2. So it will be twice of angle 1 plus angle 2, which is equal to 180 degree. So 2 ones are 2, 2 90s are 180, and so it is angle 1 plus angle 2, that is equal to 90 degree, and therefore angle BAC is equal to 90 degree, and therefore we will write that therefore triangle ABC is a right angled triangle.